Hi everyone, welcome back to the Utah SBS demo lecture series. I'm Chandler.
And I'm Marcus.
And we are the outreach office here in the Utah chapter. Today we're going to be going over the conservation of angular momentum and also gyroscopic precession. Marcus here is going to help you with this. So basically, first let's go over the physics of angular momentum, conservation of angular momentum. In this demo, how it works, we have this wheel on a free axle, and we're able to get it spinning really, really fast. What happens is, with the rotation spinning this way, we have an angular momentum pointing up vertically, and let's just give it some magnitude, call it L. And then when you change it, you flip it. Now the angular momentum is pointing in the opposite direction, so it'll have the opposite sign, and so it'll have magnitude negative L. So the total change in angular momentum is 2L. And in a closed system such as this, the angular momentum is conserved. And so what happens is, if you're standing on a rotating platform, the entire system, so you and the wheel, will begin to turn in one direction to make up for that change of angular momentum. So let's actually see this in that round. I'll get it spinning as fast as possible. Okay, go ahead and hold it.
All right. And if we change the angular momentum, voila.
Perfect. Great. Awesome, so that's the conservation of angular momentum. And now let's go over gyroscopic precession. So with this, we have to know about torque and its relation to angular momentum. Torque, like force, torque is analogous to force in a linear system. When you apply force to an object, you are increasing its velocity and therefore its momentum, mv. And so torque is similar to that. You can think of it here, if we're looking at it this way. As I hit down on this, I'm applying a force down, and that's creating a torque out, so it's increasing the angular momentum in this direction. Now if you look at it this way, if I take a rope, there we go. Woo, did not work. Oh, let's go like this actually. So if I'm holding the rope here, you can see when I let it go, the wheel wants to rotate like that. So what's happening is gravity from the center of the wheel is pulling it down, but my rope has a tension force that's pulling it up here, which is making it want to rotate. And so when that happens, there's actually a torque that's applied in this direction. And because torque is the rate of change of angular momentum, when the wheel already has momentum like this, or angular momentum, and I release it, it's going to start to rotate. The angular momentum for the wheel is going to chase the torque vector, and we get precession. And that's it.